Hi everyone, this is a solution video for Q25 Mathematics question number 22. It's a Mark 1 question and this question related to topology. Okay, so let's read the question first. Question reads as follows. Suppose we have two functions f are to 2 odd and g are to 2 odd. Okay, and the formulas function f and g are given, and we have few statements. First statement tells that for any compact set k, its inverse image also compact. The second statement tells that for any compact set k, the inverse image of that via G is also compact. Now we need to find out which option ABC is correct. That means, in other words, we need to understand H1 or H2, which of the statements is correct, both correct or not. That's what we need to understand. Okay. Okay. So that's the question. So okay. So before solving the question, let me display the NPTEL analysis course references, which can be used as a study material for solving this kind of problem. Okay. So here I'm displaying NPTEL University course references, which can be used for lecture material as for solving this kind of problem. Here the relevant YouTube link is given. You can directly go to this lecture and watch to get a grasp of solving this kind of problem. Now, before solving the problem, let me state some important theorems which can be used for solving this problem. Okay, so let me display it. So the first fact tells that under which circumstances the inverse image of compact set is compact. So suppose we have function f which is continuous, which is obvious. I mean, we need to have continuous. The previous compact set is always closed, and it is compact if f is closed, proper, or coercive. That is, the pre-image of bounded set is bounded. That means inverse image of a compact set will compact if is closed map and as well as proper or coercive. Okay, if these properties are getting satisfied, then we can directly say that function have that property. Okay, now the second fact is that the coercive thing, so there is a big, so the coercive thing in general is difficult, but whenever the function f and g, these are basically quadratic forms, basically polynomials terms. These are only polynomials. The polynomials are 2. So in that case, the coercive property is nothing but fx going to infinity and mod x going to infinity. Okay. So checking this property will ensure the given function is coercive or not. Okay. So these are the two key facts which we're going to use. Now let's solve a problem. Okay. Now the solution goes as follows. Okay. So, okay. So for the first function f, according to the formula, it can be written as follows: x minus x1 minus x2 whole square equal to 0. So now if you take k is equal to 0, 0 is singleton, so it is compact. Okay. The f inverse of 0 is equal to basically diagonal. So this can be written as diagonal of R. Okay. And of course, so basically diagonal R means what? The graph of diagonal looks like as follows. So this is this diagonal of R. Okay. And this is clearly unbounded. So the statement S1 is false. Okay. Why? Because it is not compact, unbounded. That's why. So statement 1 is false. Now for the second statement, the function g is given as follows. Now observe that this thing can be written as, so I mean, okay, so this implies what? Mod g greater than equal to 2 times x1 square, which is quite obvious, right? So this tells what? So no sooner we have this pair x1, x2, its norm going to infinity. Its norm means what? X1 square plus x2 square. This pair is going to infinity. Immediately we can say that g1, g2 going to infinity. Why? Because g, this is greater than equal to 2 into x1 square. And this is going to infinity. So mod of g shall, sorry. So mod of g shall go to infinity. As well as this will go to infinity in all direction, because initially we did not specific any choice. We simply chose the fact that norm x1 x2 going to infinity. So it tells that g x1 x2 going to infinity in all directions. So that tells that g is a coercive function. So this implies what? This implies g is coercive function. Okay, and so this tells that g is continuous and its pre-image is closed, and G inverse K is bounded also. Okay. So G satisfies all those properties which we have shown in the key facts. So that's why the statement, the S2 is true statement. Okay. So S1 is false and S2 is true. So now let's get back to the options. Option B is correct option. S1 is false and S2 is true. Okay. So that is the solution for this problem. Thank you.